Many people believe PLCs are completely safe because they are locked inside a factory. No internet connection, no risk. But this assumption is wrong. Attackers do not magically appear inside a PLC. They travel through a chain of connected systems, step by step, from the internet all the way to the PLC. In this video, we will follow that exact path. Before understanding the attack, we need to understand the normal setup. Industrial facilities are divided into two separate networks. The IT network handles business operations, emails, files, and office computers. The OT network controls the physical process, PLCs, sensors, valves, and HMIs. A firewall sits between them, deciding what traffic is allowed to cross. The path from the internet to a PLC follows a well-known structure called the Purdue model. At the top sits the internet and corporate office systems. In the middle is a security zone called the DMZ, where the firewall and remote access servers live. Below that is the operational technology network with engineering workstations, SCADA servers, and HMIs. And at the bottom are the PLCs connected directly to the physical equipment. The most common first step is not technical. Attackers target people. A phishing email arrives in an engineer's inbox disguised as a routine maintenance notification. The engineer opens the attachment. That single click installs malware silently in the background. The engineering workstation is now compromised, and that workstation has access to both the IT network and the OT network. After compromising one machine, the attacker moves quietly through the IT network. This is called lateral movement. They search for shared file folders, saved passwords, and other connected computers. One by one, more machines fall. The attacker is building a map of the network and collecting credentials, all without triggering a single alarm. If the connection between IT and OT is weak, the attacker can cross into the operational network. Many facilities leave remote access systems enabled for vendor support, sometimes years after the job is finished. Attackers find these open doors through internet scanning tools. One compromised VPN session is enough to step across the firewall into the OT network. But what about systems with no internet connection at all? Air-gapped facilities? There is still a path. A USB drive. An attacker infects a USB with malware and finds a way to get it into the facility. A contractor, an employee, or even a visitor physically carries it inside and plugs it in. No network connection is needed. This is exactly how Stuxnet reached the Iranian nuclear centrifuges, carried across the air gap on a USB drive 5 separate times. Once inside the OT network, the attacker focuses on the engineering workstation. It contains the PLC programming software, the project files, and most importantly, an authorized connection to every PLC on the network. The attacker downloads a modified program to the PLC using the same trusted industrial protocols used by the control system every day. There is no authentication challenge. The PLC simply accepts the new logic. When the PLC logic changes, the physical process changes with it. Valves open too far. Pumps run outside safe limits. Tank levels drift into overflow. The operator sees alarms on the HMI screen, but by then, the process has already moved beyond safe conditions. What started as a phishing email has now reached the physical world. Reaching a PLC requires overcoming multiple layers. Each layer is a checkpoint. Multi-factor authentication stops phishing. Network segmentation limits how far an attacker can move. Proper firewall rules block IT to OT crossings. USB port policies stop air-gap attacks. And monitoring tools detect unusual commands sent to PLCs. Cybersecurity is not a single product. It is defense in depth, many layers working together, so that breaking one does not mean breaking everything.